Today we're going to talk about set theory and set notation, and this section will be an introduction into how to group things and a lot of notation and terminology that is used in that process. Let's get started. So we have two terms to talk about here. The first term is set. A set is a well-defined collection of objects, and usually our set is labeled using a capital letter. But it can be anything. It could be colors, it could be letters, it could be numbers, it could be people, it could be anything that you can tie together using some kind of common characteristic. In addition to a set, we have element. So a set describes the things, the element are the actual things, they're the objects within the sets. And they're usually lowercase letters when you're referring to a specific element, like person A, person B, or person C. Here we have an example of a set. So in this set, the name of the set is A. And again, just to reiterate, usually sets are named with capital letters. The elements within our set are the elements W, A, R, and D. Something that's very important to note about the elements within a set is that the order of the elements does not matter. However, we can never duplicate things. So if we're combining sets together and two sets have a similar element, we don't write that down twice. And the last thing to talk about here is the notation. So if we want to talk about elements, we have this weird little symbol here, kind of like an E looking thing. But the statement W is an element of set A is written as W in our element symbol and the name of our set. So this is how we would denote that something is an element of the set, meaning it belongs to it. Some more terminology for you here. We have the universal set. The universal set establishes all the possible elements. So for example, if I establish the universal set to be the set of whole numbers, that means that I can't have any decimals or any irrational numbers in that. If I decide that the universal set could be all of the colors, then I wouldn't have anything that's not a color in there. Or maybe I want the universal set to be all the football teams, then I wouldn't have any other sports teams in that set. So a universal set defines what we can look at. Once that's established, any other set that can be made from it is a subset, which means it's a smaller collection of objects. So, for example here, let's say that I want the universe to be all of the NFL teams. Then two pretty easy subsets are the NFC or the AFC. Or if I want the universal set to be whole numbers, then we could have two subsets meaning even and odd numbers. So a subset is again just a way that you can define a smaller collection of that larger universal group. The empty set, or the null set, which is commonly referred to, is a set with no elements in it. It's kind of a defined thing or a given thing. We don't usually use it, but it's a part of every, or it's a subset of every set. And for our notation, for the subset, or for the empty set, sorry, we have a 0 with a slash through it. So that is the empty set. Now that we've talked a lot about sets, there are some different ways that we can represent them. One of the more common ways to represent a set is roster notation. And in roster notation, as it states below, every member of the set is listed. So let's look at an example. If I define set A to be the set of numbers 1 through 10, for my roster notation, I'm going to simply list all the numbers from 1 to 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If I define set B to be the set of the colors, red, blue, orange, and green, then for my roster notation, I just list out all of the colors, red, blue, orange, and green. So again, roster notation means that you list everything within the set. Alright, your turn now. I want you to try and write the roster notation for the two sets. We have X such that X is a letter in the word Mississippi, or X such that X is a multiple of 10 between 10 and 60. So go ahead and hit pause now and try that. Okay, so let's see how you did. We have the set X such that X is a letter in the word Mississippi. So go write down all the different letters in that word. We have M, I, S, and P. Those are all of the different letters, and again, we don't repeat things when we're writing out roster notation. Looking at our second set, we have X such that X is a multiple of 10 between 10 and 60. So the word between here is very important because it means that we're not including 10 and 60. So we have only 20, 30, 40, and 50. If I were to change that word and make it from 10 to 60, then I would include both those numbers, but because it says between, I'm not including 10 and 60. So watch out for those words when you're writing down your sets. Our second common way of writing out a set is set builder notation. and that is basically a rule that describes all the characteristics of the elements in the set. So here are two examples here. I have A is a set of the numbers 1 through 10. So I need a rule, and the easiest way to do this is basically your rule is the statement that's given. So our rule is that the number must be between 1 and 10. The difference here, or the addition, is you have to add in the first part. And that x line x states x such that x is. So basically all we have to do is take this notation and put it at the beginning of our statement to turn it into set builder. If you look at example B, we have B as a set of all the colors red, blue, orange, green. So once again, all we really need to do is take this initial notation, x such that x is, and put it at the beginning. And we have our answer. So we see that we have x such that x is one of the colors red, blue, orange, or green. Alright, your turn again. So I want you to go ahead and write each one of these sets in set builder notation. The first set is the numbers 1, 3, 5, 7, 9, 11, and 13, and then we have the set of soccer teams in the MLS. So go ahead and hit pause and convert these into set builder notation. Okay, so let's see how you did. Looking at our first set, again, when we're doing set builder, we got to come up with something that defines the numbers. And we want to start by saying that x line x is, and then our description of numbers is that they are an odd number from 1 to 13. Looking at our second set, the rule is already given to us. The teams are all in the MLS. So we just have to add in the beginning part, x such that x is, and then our description is a soccer team in the MLS. Alright, we talked a little bit about subsets before, now we're going to define them. A subset is a set that is fully contained within a larger set, which means it's a smaller portion of that set. Looking at our set A, we could group any amount of elements we'd like together. I've done a few for you, just kind of give you some examples. So set B would be the elements 1, 2, 3, and 4. Set C could be the elements 5, 6, 7. And then set D would be 8, 9, and 10. Again, these are all subsets because each one of the elements, if we look at our sets, all of 1, 2, 3, and 4 are in our set. All of 5, 6, and 7 are in the initial set. And 8, 9, and 10 are again in the initial set. Now in order to write the notation for this, we have a specific symbol. So here we have that B is a subset of A. And you can think of this as an inequality sign. B is less than or equal to A. Since B is specifically less than A, we don't need that line underneath. But a set can always be a subset of itself. So I could say that A is less than or equal to A if I wanted to change this. Looking at our other sets, we have C is a subset of A, and we also have that D is a subset of A. So they each have that inequality-like symbol. Alright, here we have an example of trying to write down all the subsets for our set. So our set are all the numbers that are between 1 and 5. So to help us out, this is set builder notation. I'm going to write out in roster. Since we have the word between, we're not including the 1 and 5, so we're only worried about numbers 2, 3, and 4. So I'm going to write down all the 2-element subsets, which means I'm picking 2 numbers at a time. So our first set could be 2 and 3, and then our second set could be 2 and 4. And I don't have to worry about reversing these because, again, order doesn't matter. So 2 and 3 and 3 and 2 would be the same subset. So I can move on to my next set, which would be the set 3 and 4. Now I have all of the 2-element subsets that are using the elements 2, 3, and 4, or the numbers between 1 and 5. I think it's also important to define here the fact that I'm using whole numbers. I should be more specific, saying I need whole numbers between 1 and 5, otherwise we could use decimals and fractions, but it's implied here that they're all whole numbers. Alright, now I want you guys to go ahead and try to write down all the subsets. This could be 1, 2, or 3 elements. So we could have a single person, 2 people, or all 3 people together. So write down all of the possible subsets for Bob, Matt, and Cheryl. Hit pause now and try that. Alright, so to make things easy, I'm going to use some abbreviations. So B for Bob, M for Matt, and C for Cheryl. So for our first sets, I'm going to list all of the individuals. So I have the set that is just Bob, or the set that is Matt, or the set that is Cheryl. And I have all of the 2 people at a time, or 2-person sets. So I could have Bob and Matt, could also have Bob and Cheryl. Or I could also have Matt and Cheryl. I could also have all three people because a set can always be a subset of itself. So Bob, Matt, and Cheryl. And finally, we can't forget we have to add in the empty set or the null set because it is always a subset. Always. Don't forget. This is the number one thing people forget to list when they're listing all of the subsets. Make sure you include the null set or the empty set. Alright, to define the term set equality, two sets are equal if and only if they have exactly the same elements. They don't have to be in the same order because, again, order doesn't matter, but they have to be the same. So if I'm looking at my two sets, I have set A, elements 1, 2, 3, and x. B has the elements 1, 2, 3, and x as well. So those two sets are equal, and we just write that they're equal. Here we have set A, which is the elements 1, 2, and 3. B are the elements 1, 2, 3, and x. So here we can see that set B has that extra x, so they're not equal. A would in fact be a subset, so they're not equal. Instead, we could say that A is a subset of B. Alright, we're going to quiz you guys here and see how much you understand in terms of notation. So we have a set, F. It's comprised of the elements 1, 2, 3, 4, and 5. I want you guys to go ahead and write down true or false next to each one of these statements. There's 6 different examples. And then check back in and see how you did. Alright, let's see how you guys did. So looking at our first example here, we have 2 as an element of F. That's what that's read as. 2 is an element of F. So to check that, is 2 somewhere in that set? And it is. So it's a true statement. If you look right below that, 2 is a subset of F. Elements by themselves cannot be subsets. It needs to be a set. And this is missing brackets. So this is a false statement. But that's kind of helps us with our third statement down here. Is the set 2 a subset of F? And since this is a set, and again, sets can be subsets of other sets, it's a true statement. Notice here we don't have that line underneath like we did with our last examples. That's because this is strictly smaller than our initial set F, so you don't have to have that underline there. Looking up at the top right, we have the elements 1, 2, and 3 are all in set F. So again, the elements 1, 2, and 3 are all in that initial set. That is true. The set 1, 2, and 3 is equal to or the same size as F, and that's definitely false because we have an additional 4 and 5 there. And finally, is F less than or equal to itself? So is it a subset of itself? And that is always a true statement as long as we have that bar underneath. If this line was not there and we had just F is less than F or a subset of itself, that would not be true. Alright, we are done with notes. You guys can go ahead and open up the textbook and get started on the homework.